Question number 12. Let A1, A2, A3, A4, A5, A6 be a regular hexagon. Write the x components of the vectors represented by the taken six sides taken in order. Use the fact that resultant of these six vectors is 0 to prove that cos 0 degree plus cos pi by 3 plus cos 2 pi by 3 plus cos 3 pi by 3 plus cos 4 pi by 3 plus cos 5 pi by 3 equal to 0. So here, if net resultant is 0, it means x components and y components will be separately 0. So let's prove it. So consider sum of x components. It will be equal to, let magnitude of each vector is capital A. So A common cos 0 degree for this plus cos 60 degree for this vector plus cos 120 for this, then cos 180 for this, then cos 250 for this vector, and then plus cos 300 degree for this. Now, let's evaluate it. So A times cos 0 is 1, cos 60 is 1 by 2, cos 120 is minus half, cos 180 is minus 1, plus cos 240 will be minus half, plus cos 300 is plus half. So all values will get cancelled and we will get 0. Similarly, sum of y components. It will be equal to A times, in terms of sine, we have to write these things. Sine 0 degree plus sine 60 degree plus sine 120 degree plus sine 180 degree plus sine 240 degree plus sine 300 degree. Now, let's write the value. This is 0. This is root 3 by 2. This is also root 3 by 2. This is 180. This is 0. This is minus root 3 by 2. And this is also minus root 3 by 2. So answer is 0. Hence, our purpose is search. Question number 13. We are given A equal to and B equal to, find the angle between them. So we are going to make use of dot product. So we know A dot B equal to modulus A modulus B cos theta. So cos theta equal to A dot B. Let's write 2i plus 3j plus 4k dot 3i plus 4j plus 5k divided by modulus of 4. So this will be equal to 4 plus 9 plus 16. This will also become 9 plus 16 plus 25. So let's simplify. 3 to the 6 plus 3 to the 12 plus 4 by the 20 divided by, this will become root 29 and this will become root 50. So it will be 38 divided by the root multiplication of the two, 1450. So theta equal to cos inverse 38 divided by 1450 with square. Now, next question. Prove that A dot A cross B. Since A cross B will be perpendicular to both A and B. So suppose A we write as AX I cap and B we write just BY J cap. Then what do we get here? So if we find A cross B, we can take another example, but we are considering simple example. Suppose we take A cross B. So it will be equal to AX BY and then I cross J. And we know if this is I, this is J, then I cross J will be K. So we have got it AX VY times K. And we can write that value here. A as AX I cap dot AX BY K cap. So AX square VY then I cap dot K cap. These two are mutually perpendicular, and we know that A dot B equal to AB sine theta. So it will give sine, sorry, A dot B equal to AB cos theta. So this will give 0 because AX square BY and this will be 1 into cos 90 degree, which will give 0. Now we can evaluate it other way around also. So let's consider another technique. So we can consider, suppose A equal to, we take full vectors. Vector A equal to, suppose AX I cap plus AY j cap plus AZ k cap, and the vector P equal to, suppose BX I cap plus BY j cap plus BZ k cap. Now we find A cross B. So for that purpose, we write I j k AX AY AZ BX BY BZ. We evaluate it. It will become I times AY BZ minus BY AZ minus J times AX BZ minus BX AZ plus K times AX BY minus BX AY. Now we have to find out A dot A cross B. So we put the values AX I cap plus AY j cap plus AZ k cap dot this value. Now, if we multiply, what do we get? We get AX AY BZ minus BY AZ AX minus AX AY BZ plus BX AZ times AY and then plus AZ times AX BY minus BX AY. If we simplify, all terms will get cancelled and we will get 0. Let's go to next question. We have to find out A cross B. The vector A cross B is I, J, K, 2, 3, 4, 4, 3, 2. Now we evaluate I times, we leave this column in this row, 3 to the 6 minus 12. Then minus J, and we note this. So 4 minus 16 plus K. So this will be 6 minus 12. So we simplify. minus 6 I cap, and this is plus 12 j cap minus 6 k cap. So answer. Question number 16. If A, B, C are mutually perpendicular, then show that C cross A cross B is 0. So here, if we evaluate A cross B, it will be K times vector C, because all three are mutually perpendicular. The cross product of A and B must be equal to K times vector C. So we have got A cross B as K cross C. Now, C cross A cross C will be 0. A times C cross C, which is clearly 0. Now, next question is the converse true? Converse is not true, because they can be parallel vectors also. If they are parallel vectors, in that case, automatically this will become 0, and then the product will be 0. Consider next question. A particle moves on a given straight line with a constant speed v. Particle is moving in this direction. At a certain time, it is at a point P. Suppose particle is here. O is the fixed point. This is a fixed point. Show that OP vector cross V is independent of position of P. So let's find out what is OP cross V. OP cross V is OP into V into sine theta. Now, we try to find out OP sine theta. So this angle is sine theta 1. So OP sine theta 1 must be equal to R1. So here this is R1 vector. Before that, let's find what is sine theta. So here sine theta 1 would be perpendicular, that's OP, divided by hypotenuse is OP. So OQ is fixed. Suppose OQ is A. So OQ equal to OP sine theta 1. So OQ is equal to A. So we can write OP sine theta 1 as A. So we have got A into B. Now, consider second case. Suppose particle reaches at point P dash. Now again, we try to find out OP dash into B. This means modulus OP into V into sine theta 2. Again, we get sine theta 2 equal to perpendicular, that is A divided by OP dash. So this is OP dash. So we can say OP dash into sine theta 2 is equal to A. So again, we get the value of this as AV. So in every case, we are getting same thing. So we can say OP cross V vector is independent of the position of P, because when we evaluate this OP cross V for point P, we have got A into V. When we evaluate it for point P dash, where angle is theta 2, in that case, again, we have got AV. So we can say the cross product of the two will remain constant. Hence, OP cross V is independent of the position P. Thank you for watching.